All right, today we have got a brand new Type B pressure meter, and we are going to show you how to calibrate the pressure meter itself. But first, we're going to show you how to calculate the volume of the pot so you can use it for unit weight. And we're going to show you what comes in a new pressure meter. So you've got certificate of calibration from Myers there. Got the pot, got the lid. This is the calibration vessel. This is what we call the candy cane, used for calibrating, along with the stem that goes in the bottom for calibrating as well. It comes with a strike-off rod, and it comes with, strike-off rod, and it comes with your standard 5/8 rod, strike-off bar. You also get these. I don't like to use these as much as I like to use just an old Dawn bottle or some kind of bottle. Even something like this I like a little better. So, but it does the job if you want to use it. And so we're going to get this unpacked, and we're going to show you how to first calibrate the volume of the bottom, the base. All right, so to calibrate the volume of the base of the pot, we're going to need water. We're going to need some type of lid. This is the glass plate we use for Adderbergs. Typically, it works really good. We won't use the rough side. We'll use the smooth side. That works to make sure we screed off the water. And you're going to need this formula. So we're going to write out the weight of the measure. That includes the lid, the plate on the top. And then we're going to write out the weight of the measure plus the water. Figure out how much water we have. That's the first step. We're going to do this in pounds. So first, you could just tear out the thing, but we're going to show you how to include it so you can go either way with it. So this is the weight of the pot and the glass. It's 13.321. So you've got 13.321. All right. Now we are going to fill it with water. We probably will fill it off of the scale so we don't make such a mess. You're going to need enough water to fill it up. We're just going to get it close. Then I'm going to put probably like a towel or something underneath it. So grab a towel here so we don't make a complete mess when we do it. That should be good. Take a little bit more water till it's right at the top. And you'll see it start to bubble over. It's pretty close actually, but you don't want it running over the lip, but you want it close. All right, then you'll take your glass plate, you put it over it like that, and you'll strike it off. So now you know that the vessel itself is completely full of water. You can use paper towels, or you can use towel or whatever you want. And you just want to dry up the extra water that you may have spilled in the middle of doing this. Because you don't want any weight on the outside of the pot. You want all your weight confound in just the water. All right, that's pretty dry. We'll transfer it back to the scale. 28.854. All right, 28.854. Probably should write that down. 28.854. All right, now you want to subtract the difference. 28.854 minus 13.321. That gives us a water weight of 15.533. That's going to be our main number. The water temp is what we have next. You want to, and we're doing all this in pounds. You want to get your water temp in Celsius. Right? Let's go this way. And we can now take the top off. Careful not to break the glass. And we're going to get a water temp of, let's see, 25.6 degrees Celsius. 25.6, you're going to need some type of unit weight of water conversion table. You can look this up, but it's not really that serious. If you find one that's a degree or something off, it's not going to move the needle much on a calibration that's this far out in terms of units. So we're going to go with 26.7 and 23.9 is what we have. And the difference between the numbers is 62.261 and 62.216. We'll just go with the 62.216. Oh, 62.216. We didn't write down the water temp, but that's not what you're trying to get to is these two numbers here. So your density, or your volume, I mean, your volume is the weight of the water divided by the density of water. So 15.533 divided by 62.216 gives you 24.96, or essentially 0.25. So 0.24966 if you want to take it out that many decibels. We'll go up to the next one as well, which was 62.261, just to show you the difference. If we took that same 15.533 divided by 62.261, it would give you 24.948. So it doesn't move the needle a lot. Us personally here, we put the units into the Excel sheet and it gives us the exact density, and that's what we go with. But for the sake of the class, I didn't want to have to do the formula because it's crazy, or for the sake of the video, it's very long and complex. But that's how you calibrate the volume of the base. All right, today we're going to show you how we calibrate the pressure meter. We're going to show you what I think the CaliCan is good for and what it's not good for. And the first step to calibrating the pressure meter is determining what is the initial pressure. To do that, we'll stick it in the sink. We're going to fill it all the way up. Got out your way, you can see good. It's easier to do in the sink because we don't have to worry about keeping anything clean. We can let water go everywhere. All right, it's full. Clamp it down, right? And then same thing, you just want to fill it up, right? Nice and full. If you have something like this that you rather use to make sure it's full, that's fine. The idea is that it's full. Once you know it's full, previously this was calibrated, I guess, from the factory at 3%. So that's where we'll start, and that is the kind of the typical point. Start there, close it. So there we go. Looks like 3 is it. 3 gets us a 0. So now we'll empty it, dry it, and I'll show you how to actually calibrate the pressure meter, or at least how I calibrate it. Okay, now that we've determined our initial pressure is 3%, we're going to calibrate the actual meter itself. We've already got our extension in the bottom. We're going to set that to the side. Oh, actually, no, wait. Before we do anything, we have to tear out the entire unit. All right, I'm just going to get that down to 0, because all we're looking for is the weight of the water itself. So that's all 0. Now we want to fill this with water. Fill the right, there we go. Put the lid on. We want to get all the water out. Right. Stop. Make sure we're good. Okay, that's pretty good. Let's get the towel right here. Okay, very good. Completely full of water. Okay, so grams, we are 7119.9. So that's our H2O water weight full. Now, what we want to do is take out any amount you want. This is 5%. So what you can do is close that pet cart, hold this one open, and you can just take out what you think is close to 5%. And the reason I prefer to weigh the vessel instead of weighing this is because I could spill this, I could spill some out of the tube. There's endless opportunities for me to screw it up. But weighing this is simple. Chances of me spilling it are a lot less. 65.7. So this, we'll call this H2O weight 1. It's not empty, but it's the difference, right? So now you take the difference. You get you a calculator. See if I can do this with my gloves on. We're going to take 7119.9. We're going to subtract the difference, 67.6765.7. That's going to be 354. I guess I can write that for reference. 354.2. And we're going to divide that by the original number. Divided by 7119.9. That's going to give us 0.049, or if you do times 100, that'll give you the 4.97, so right at 5%. So this should equal 5%. Which makes sense because this is 5% air, right? Now all you have to do is test. The absence of water is the presence of air in this case. So you would test it to our initial pressure, which we've already determined earlier. Remember, after you pump it real fast like that, to give it a second, let the air cool down, let it stabilize. And we hit it right at 3. Must be living right. And then you just test. And keep your hand on this to let all the air have a chance to make its way into the gauge. That is exactly 5%. Now, if you want, make sure not to open this one because this has the extension in it, right? It will just squirt. This one should have air. Release it slowly. All right, so just air. Now, if you want to take more out, you can test it at 7% or 8%. All you have to do is reweigh it. In our case, let's take a little bit more out. Let's take this. Let's take just a little bit more out and see what happens. Let's just see what that does. Again, I don't have to keep up with how much I'm taking out because I'm weighing the vessel. It's much easier to keep up with the weight when you're only weighing what you're taking out of the vessel instead of weighing the actual water you're taking out. So we're at 66.25. So we'll just do a new line here. 60. That's a terrible 6, isn't it? 66.25. Is that 0.0? 0.0, yeah. And we're going to do the same thing. We're going to do 71.9 minus 66.25. That's going to give us the 494.9. I'm going to divide that back by the original number. 7119.9. So now we should have exactly 7% air. If you multiply it by 100, 7%. Let's test it. See what we get. Once you start getting up above 7 or 8, it gets dicey. Really above 8. All right, so we're right on 0 or 3. Again, give it time to get right. We are right at 7%, right? That is how you calibrate it. If you add water back in at this point, which is totally fine, you can take one of these, add as much water as you want back in, reweigh it, and you're still going to do the same math, and you're going to be right where you were. And that is how you calibrate the pressure meter. All right? Everyone's favorite. Let's talk about the Pro Cali can. This is made to represent 5% air. This calibration vessel represents 5% air by volume when placed in any quarter cubic foot pressure meter bucket base. Make quick and easy checks by placing Pro Cali can upright at the bottom of your pressure meter bucket. The best way is to place the Pro Cali can in an already filled meter bucket. Pro Cali can upright. Place Pro Cali can upright as you place it on the bottom of the bucket. Pressure meter cover on and basically test as normal is what it's saying. Use 2 of these if you want to check it at 10%. So I'm going to show you why this is only used as a check and should not be used as a calibration vessel, at least not in my book. Okay, put that in. Put this on top. I'm going to make a little bit of a mess here with water, so that's okay. Right, so we'll take that. We'll fill it back up. Do I have enough water? Oh yeah. All right, so we got enough water. It's full. Now let's test it again. See what we get. In theory, we would get 5%. Nope, I let too much up. Still too much. That's tight. We're good. At the 3% mark. Hard to tell. Maybe a little bit more. All right. Now that I can see. All right, so we're right at 3%. Tighten that up. Hold it down. Now, we should get 5% in theory. But what you're going to see, after we let it set just like we previously did, you're going to see that we get about 4.8, 4.7%. Okay? The reason that you're getting a little bit less is because while the volume here says 0.25, 0, it's rounded to the 3 decimal. The actual volume of this vessel is 0.24 or 0.296777 blah blah blah. The 5% vessel, the Calican, only represents exactly a quarter of a cubic foot. So since it's 5%, it has to be 5% of something. So in this case, if the vessel isn't exactly 0.25, the Calican cannot represent 5% of that. It has to represent less or more, depending on the vessel. And so the way we would use the Calican is that we would know this Calican in this pressure meter assembly represents about 4.8 or 4.9% moisture. We would document that maybe on the side, maybe on the calibration sticker that we put on it later. And that's the way we use the Calican. We don't actually use it to calibrate the vessel itself or the pressure meter itself. And so for what it's worth, let me know how you calibrate with the pressure meter, or how you calibrate the pressure meter and how you use the Calican in the comments. And that's how we do it here.